Hello and welcome to the Airborn Math Show, where you get the scoop on planes. Today we have Jim Greer here with us. What is your occupation, Jim?
I'm an FAA certified A&P mechanic.
What exactly is that?
That means I'm certified by the Federal Aviation Administration to work on aircraft.
So you work on airplanes?
Yes.
How do you use algebra to keep those wing death traps working?
Well, you use algebra in a lot of ways on an airplane. You use it for fuel flow, manifold pressure graphs, weight to balance ratio.
Whoa. Let's break it down. When would you use equations in repairing those big birds?
Well, I guess you'd use it on a lot of things like fuel consumption. If you want to know how much fuel it used over a certain distance or how much it's supposed to use when you're making adjustments and tuning it and repairing it.
Could you relate that to something that Ms. Holcomb would understand?
That she would understand or the students would understand?
That she would.
I'll put it in very simple terms. Let's see if you have a propeller that's spinning 3,000 RPMs and you need to know how much fuel per hour it burns. And that would be one of the ways that you would look at it. Or if you wanted to know what the manifold pressure was, then you could use algebra to determine where it's supposed to be and adjust it.
Okay, seems simple enough. Moving on. What do you use graphs for when screwing around with all those parts?
We use graphs on a horsepower to fuel consumption chart and a fuel flow chart to RPM. So depending on how fast the engine's turning, a certain amount of fuel should be going through it.
Can you draw us a mental picture?
Yeah, it'd be just like a graph that you normally look at. On one side would be engine RPMs going up on the vertical axis, and on the horizontal axis would be fuel consumption or fuel flow.
Okay. What about when would you use transformations?
Transformations would be used sort of like when you have control surfaces that need to change, like ailerons or rudders.
Okay, can you give a more in-depth example?
Well, yeah, the Wright brothers, the Wright Flyer, they used wing warp instead of ailerons, so it absolutely changed shape to change the aerodynamic qualities.
Interesting. When do you use linear inequalities?
Probably when you're adjusting a vacuum gauge for your vacuum system.
Can you put that in simpler terms?
Yeah, a vacuum system on most general aviation aircraft. If you've ever seen a picture of the cockpit of an instruments in an airplane, you'll see the little airplane on the horizon, and the top half of the instrument's blue and the bottom half's black. It represents the sky and the angle that your airplane is in relation to the ground. That's run by a gyroscope that is run by a vacuum system, and the vacuum has to be within certain tolerances.
Okay, nice. What would you use precision for?
I use precision on just about everything on an airplane, especially if you're doing a major overhaul on an engine.
Can you go a little more in depth in that?
Sure. All the tolerances, let's say on a reciprocating engine, which is a piston engine like your car, you would have to precisely measure the crankshaft, the cylinder bore, the valve guides, just pretty much everything in it has certain specific precision tolerances that it has to fall within.
Interesting. When do you use ratios in working on those metal coffins?
Metal coffins. I use them in lift to drag ratios and also horsepower to weight ratios.
Can you simplify that, please?
Yeah, let's say an airplane develops 100 horsepower and it weighs 1,000 pounds. So that would be, I guess the ratio would be 10 pounds per horsepower.
Okay. How do you use variables to keep those airplanes modest?
I guess you're talking about covering them. So, because some of the older airplanes used fabric covering, like this one we're working on right now. That was a tap of a hand on a fabric wing, and to cover this wing, you would have to use we get the square area of the wing, and then you got a top and bottom, so you double it, and then you add another 20% for waste.
Did y'all get that? Thank you for being with us today on the Airborne Math Show.
Thank you.